So this is the first lesson we taught last year in 6th grade math. So those of you that are here, you should know this. When we are using distributive property, we're multiplying each term inside the parentheses by the number outside the parentheses. So here's where hopefully it will start to ring a bell. The easiest way to do this is just draw an arrow from that outside term to each of the inside ones. Okay? Whatever it is, it doesn't matter if it's the number or variable, you're multiplying it by each of the inside ones. So A times B would equal AB. Whatever my sign is, and here's where it's going to get a little different now that we have done negative integers. You kind of need to compare them using the signs that are with each one before you can really determine what's on the inside. But the easy way to say on distributive property is this isn't actually going to change. Whatever it is going to fly over. And then I multiply the outside times the inside. So AB plus AC. Again, it doesn't matter what the sign is on the inside. The process is always the same. I take that outside times the inside, so that's AB. Whatever my sign is, it's just going to float on over. And then you multiply the inside and outside, AC. Here's where the difference is going to be. Now that we have done integers, that sign could change, especially if my outside number is negative. So if whatever's on the outside is negative, that's going to change what actually happens on the inside. So again, what I really, really need you guys to do is stop thinking about this as adding and subtracting, and just thinking about each of the numbers as integers themselves. Yes, Nolan?
Are we going to start getting into parentheses inside parentheses because of like negative numbers?
Somewhat yes, but not in this lesson.
Okay.
But as we continue moving forward, you will start seeing more nested expressions.
Okay.
Yes, and that's what we call it. If you have parentheses inside of parentheses, that's called a nested expression. Okay? Now, here's that second part that I was just talking about. Be careful with your signs when multiplying positive and negatives. Okay? You really have to keep track of those rules. That's why we did the whole integer piece before we moved into the equations. As you're doing distributive property, those integer rules apply. Okay? Any questions so far on just the basics? So I kind of like this lesson because we're going to get right into it. We're going to have you guys build a problem to see it, and then we're going to do a whole bunch of problems together. So let's go ahead. I'll let you guys work together. Pay attention to all your directions. They've given you the scenario and the basis to form everything. So we'll give you guys about 4 minutes to work through this together. Okay, on this one, at a candy shop, a group of 3 friends each bought a lollipop, 2 candy bracelets, and 3 gummy worms. Each individual purchase can be represented by the pictures inside the parentheses below. So, what number should go outside the parentheses? Alana?
Oh, 3 because it was a group of 3 friends and they each bought those items.
Good. The 3 goes out there because there were 3 friends who each bought everything on the inside. So we're okay with that? Okay. Write an expression under each picture to represent the items. So we're supposed to write the expression underneath it. So for the lollipops, what would I put?
P.
P. For the 2 bracelets, 2B. And for the 3 gummy worms.
3G.
Is everybody okay with that? Does that make sense for everybody? Okay. Once we have this, now we're going to distribute and simplify the expression. Meaning, I'm going to take this expression, 3 times P plus 2B plus 3G, and I'm going to distribute to each of the inside terms. Now here's where it gets a little different. Most of them, we've only been doing 2 terms on the inside. Does it actually matter how many terms are in the inside? No. If it's on the outside of the parentheses, everything is being distributed to it. So that means I now have 3P plus 6B plus 9G. Now, is that in simplest form?
Wait.
Yes? No?
Yes.
Yes. The only thing I would do, because I do kind of like to try to do them in order, so I would rearrange it. Just, for me, that's better. But if this is your answer, you would not lose any credit, because that is what it says.
Put it in that order.
Because that's alphabetical. Remember I said we normally do it alphabetically?
No.
Oh, that's right. You'd have to listen to understand.
My ears are made up.
Okay, any questions on that one? Okay, now this next section, we've got 5 different problems for you to do. Actually, the 4th one is actually like 4 problems in one. So technically it's 8 problems, so I'll give you guys about 4 minutes to do this. Basically finish off this side of the paper. Okay, again, remember, when I'm distributing, you have to remember your integer rules. So the first thing you need to be doing is looking at your positive and negative signs. I feel like the arrows help, and they're not required, but if it's going to help you, I would definitely recommend doing them. Because it's going to make sure you're doing everything you need to do as well. So in this case, because they're both positive, I just multiply that 16g. My sign, I treat that basically as a -9 in my brain. So -9 times 8 means it's going to be a -72, so I just keep it as a minus. Okay? Our next one, here's where the integer rules really become important, because my outside number is a negative. That's actually going to change how I'm going to write the inside. So this one becomes -5 times 13 becomes a -65d. -5 times 11 is actually -55. So instead of writing plus a -55, I would just make it -55. This is how I want you guys to get used to writing it. If you wrote it as -65d plus a -55, you are technically correct, and I would be okay with that. Okay? So if you're not ready to make that leap into just thinking of these as integers, and you still want to focus on the operations, then you're going to be doing it like this. But I really, really want you guys to get used to -5, positive 11, that's a -55. Does that make sense for everybody?
Maybe.
Peyton, you good?
Yeah.
Mr. Stretch? Okay. Okay, our next one. Again, we have a negative number on the outside, so that's going to make these integer rules really important. First, I do the math. 4 times m is 4m. Negative times negative is positive. 4 times 8 is 32. Negative times negative is positive.
We could do that? I thought I counted as like not showing a word.
Do you see the arrows?
Yes, but
Do the arrows show the word?
Yes.
yeah.
See, the problem is, Danny, you're probably not going to show the arrows.
Oh, actually, I have the arrows for the first time in history.
Oh, good. So I'm making an impact on you.
Yeah, you're making a huge impact. That's why
Nice.
it's so awesome.
Okay, the last one, you guys are supposed to do all of them, so you had to do all 5 of them, and then figure out which ones matched up. So again, I'm just going like this. I would just do them up top without even looking at the bottom, just to get your answer, and then you should be able to see it. If you don't see it, then you need to realize you made some kind of mistake. So this one, they're all positive, so that becomes 8x plus 12. 8x plus 12, I see right over here. Here we go, we got 8x minus 12, because 4 times a -3 is a negative. So 8x minus 12 is going to be here. Here we've got -8x minus 12, because negative times a positive is a negative. So that one matches up here. And -4, so that gives me a -8x. Negative times negative is a positive. -8x plus 12, that was straight down. Any questions on any of these? So get it all in, Maria?
I don't have the paper.
Oh, now you tell me.
Oh,
That's a shock.
imagine.
Any questions, guys?
Wait, do I have a straw?
Okay, let's go ahead and go to the back side.
No, let's-
On the back side, you've got 7 of them right up top. So go ahead and do all 7 of them. I'll give you guys about 8 minutes. Again, all we're doing is carrying that outside to both of the insides. Remember, multiplying is the easiest one. I just do the math, then I compare my signs. So 8 times 4 is 32y. Negative times positive is a negative. 8 times 5 is 40. Negative times negative is positive. If you wrote this one as negative 32y minus a negative 40, technically that's okay, but again, this is what we're trying to get away from, is doing that double negative. Okay? So I really want you guys to just do that math, and then apply it, and then use the appropriate addition or subtraction on the middle. Next one. And here's an interesting one. I just want to do a quick survey. How many of you had to do 12 and 5/10 times 3 on a separate side?
No one.
How many of you did 12 times 3 is 36, and then half of 3 is 1 1/2, and 36 and 1 1/2 means it's 37 and 5/10.
You watched me, like, I was about to raise my hand, but then you just, like, said something. Yeah, I did the first one. I did math.
I did that one.
How many of you did it mentally versus having to write it out?
Oh, I did mentally. Yeah, I did mentally.
Okay. Guys, here's the difference. If I go look at all of your papers, I was grading so I didn't see everybody. I would imagine a lot of you did this, right?
No.
15, 7, 37, and 5/10. Here's what I did, and here's where the distributive property is really helpful. I said, well, this is 12 times 3 plus 12 times, or no, plus 0.5 times 3. Because I can do this mentally. I can say, oh, that's 36, and this is 1 1/2. If I put those together, that gives me 37 and 5/10. So this one is what I do mentally, which is distributive property.
That's what I was thinking.
I did the second one.
Okay?
So that's actually what I did in my
No,
I did
wait.
the second one, but in my head, which I don't think that's a good thing, is it?
No, it is. That's what I literally just said.
Wait, I did 3 times 12.
Shane, you can go replay the video and you'll hear that's exactly what I said.
Nice.
This is good if you can actually do this mentally, but mentally, most of you are probably using distributive property and didn't even realize it.
Wait, yeah, that's what I did.
This one is
I never
distributive
got this
property.
community associative identity.
You gotta understand all your properties, Shane. They're very important for mathematical work.
Well,
Hold on, one at a time. Nolan's actually had his hand up instead of just
Me
blurting
too.
stuff out. Nolan?
I think you and me have very different brains because I did not do either of those.
What did you do?
I just multiplied it.
That's the first one.
Like I didn't write it down. I just multiplied it.
So you did this one, you just did it mentally.
Yes.
That's okay.
Well,
Those numbers are easy enough, you can.
Wait, this is
But if we get into some of the more advanced math, you'll see that it's actually easier to use that distributive property, break the numbers into pieces, and do the pieces and put them together. Yes, Danny?
Oh. God, does that tell me, like, do I have to show my work, like, write it out that?
Okay, Danny, I've said this 5 times already. How do we show our work on this?
No, I know, but like.
That is showing your work, Danny. That's showing me that you understand what you're putting together.
He's asking me
That
if
is-
that's all he has to do, like, he's just confirming.
I've said it like 8 times.
No, so I don't have to write out on the side 12.5.
No, I literally just said. If I'm doing it mentally, this is how I did it. Did I show you the work on that, or did I write it, and then I was interested in how you did it?
You just wrote it?
I just wrote it.
So I could, like,
So, do I not model for you what I expect out of you?
maybe?
Always.
Oh.
So if I just went from the arrows to the number, do you think I expect you to be able to go from the arrows to the number?
Yes.
Yes.
Oh. Okay.
So what is your work? Your work is the arrows. If you don't do the arrows, and all you do is write down numbers, yes, then I have an issue. Then I need to see something over to the side for where you got those numbers from. But if you show me the arrows, I know where you got the numbers from because you're showing me your work. Okay?
I do either of those ways.
Which way did you do it?
3 times 12 and then 3 times 25 and then I just add those.
That's the second one.
That's this. 3 times 12 and 3 times 25.
I don't think you could see.
Then you add them together. Because you got the whole board back there. Okay, so anyway, so that's my first term. Then I have 12 and a half times 12 times 2, so that's 25W. They're both positive, so it's positive. Next one. I didn't hear it this class, but last class was really fun because I had a student say, wait, 1/2 times 6, how do I do that? I'm like, you don't know what half of 6 is?
No, I don't. It's 3.
I know you don't, Danny, but that's okay. Oh, sorry, Shane. 3 plus 5.
Oh, you're so mean to me. What did I ever do to you? Let's go.
Okay, questions on that one? Good, next one. Here's where we're getting even more fun, because now we have to make sure we understand how to multiply our fractions.
Yay.
Now, this one, I would start to expect to see some of you writing your workout. So if I'm doing 2/3 times 3, my 3's cancel out, becomes 2 over 1, which is 2. So that means that first one is 2F. 2/3 times 12. I can do a cancellation. 1 and 4 gives me 8 over 1, which is 8. So that's plus 8 plus F. And here's where the simplifying, finding like terms comes in. Don't forget that this one was still here. So I need to still account for that. Now I've got my 2F and my F. I can put those together, give me 3F plus 8. That should have been your final answer. Next one. They gave me a single term first. My distribution actually doesn't happen until the last part. So now I go 2 times 9 is 18. 2 times 1/4, just in case any of you don't know how to do that one. Again, I just simplify, it gives me 1/2. So that's 1/2 x. Positive times negative means it is negative. But I also have 3/4 x that I need to account for. Now I combine my like terms. I have a positive and a negative, means they're different, they're going to fight. So 3/4 minus 1/2. First thing here, I've got to have a common denominator. Makes that 2/4. 3 minus 2 gives me 1/4. Bigger guy is positive, so that becomes 1/4 x plus 18. Should have been your final answer.
Yep, I got that too, Lynn.
And I think this is your last one, right?
No, I got 2 more.
2 more? Okay. So again, once my negative is on that outside number, you really, really have to pay attention to your integer rules. The nice thing is it's a 10, that just means I'm moving my decimal ones. So that becomes 32 and 5/10 C. Negative times positive becomes negative. 5 and 5/10, I just move it once, so that becomes 55. Negative times positive becomes negative. Don't forget the additional term that they put in there. So I still have some simplifying to do. I have 2 negative numbers. Again, think of them as numbers, not just minus. So if they're 2 negative numbers, that means they're the same. That means they like each other, so I'm going to put them the same, keep the sign the same. So negative 32 and 5/10 C minus 75. Any questions on that one? There's actually a lot of the integer rule pieces in that. Is everybody okay on this one? How many of you got that one right? Raise your hand. Okay, those of you that didn't get it right, you understand the mistakes you made. Okay. Here we go. So 2500 times 4, so that's just going to be 1, but it's a negative, so negative 1g. 2500 times 6, so that's going to be 1 and 5/10. Negative times positive is a negative. I still have the 13 out here. Please don't forget the additional pieces. So you're going to want to do the distributor property first, because you got to, that's order of operations. I have to multiply before I do the addition and subtraction. Now I'm looking at my numbers. I have a 13 and a negative 1.5. Opposite means that they're going to fight. 13 minus 1.5. I need to add my trailing 0. Becomes a 5, 1, 1. The bigger guy is positive, so that becomes 11 5/10 minus G. Because normally we don't write that 1, but 2500 times 4, that was just natural for me to write a 1. If you write the 1G, I wouldn't count it wrong. But remember, just mathematical practice. Normally, we don't put 1 when that's my coefficient. Mia, you tracking on this? Because you look awfully intense in something that you're not supposed to have out now. Thank you. Questions on this one? Danny?
Why is it minus 1.5?
What's negative times a positive?
Oh. Wait, oh, so... Minus... Oh, so negative 2.5, no, negative 0.25 times... Oh, then got it.
Got it? So, but Danny does bring up a point. If you're not thinking this as a negative, that does make your math a little harder because you're going to have to keep track because you're actually going to be subtracting the 2500 times 6, which is a positive, but it still comes out minus a plus 6. Or minus plus 1.5. Okay? So you got 2 more left on this paper. Go ahead and knock both of them out. This one should only take you about 4 minutes. I will tell you, given first period, make sure you're paying attention to what they're asking you to find. Okay, our last 2. Simplify an expression for the area of the rectangle. What's my area formula?
Length times width.
Length times width. So, I have a length of 20 and a height or a width of 4 2/5 x minus 5. So, 20 times the quantity, 4 2/5 x, minus 5, meaning I need to distribute 20 times 4 2/5. I do have to do slam dunk on that one. So, slam dunk gives me 22/5. Gives me 1 4, so that would be 88x. 20 times a negative 5 is minus 100. Is there anything else that I could simplify on this?
No.
No, there's not. So that's my simplest form right there. Okay? Your last one, you had 3 of them that you had to check. So they're supposed to create an expression that includes the distributive property and simplifies to negative 10x plus 20. Circle the name of any student who correctly completed the task. So your first thing to do is just go ahead and show your work. Negative 10x plus 20. Is that what I was shooting for? Yes, so Journey did it right. Kai said negative 2 times negative 5, that's 10x minus 20. Did they do it right? No. 5 times a negative 2x, that gives me a negative 10x. 5 times 4 is 20, it's positive. Did that one do it right? Yes, so should have had 2 of them that were correct. Any questions on distributive property? Okay guys, again, your biggest pieces, make sure you're looking at them as integers, and then your final answer has the correct integers. So change the addition subtraction for what it is. When they add extra pieces in, you have to do distributive property first, and then you're going to add in the extra pieces to simplify. Okay, good luck guys.